Good afternoon, everybody. Happy Cinco de Mayo. We're glad you could join us today. We can't see your video, so if you're enjoying a beverage to celebrate the holiday, we won't know it. But we hope you enjoy our presentation. Today, we're focusing on tools to help the design community mitigate the climate crisis, in particular, help advance net zero energy designs in their buildings. We have a great couple of presenters today. Before we get to that, though, some housekeeping notes. I'd like to invite you to use the Q&A feature that is located at the bottom of your Zoom interface screen. If you hover over that, you'll see participants chat, share screen, and Q&A. So Q&A is a way to get your questions answered. We'll be monitoring those throughout the presentation. If it's something that needs to be answered right away, I'll be sure to interject that question. If it can wait till the end of the presentation, we've got time built in for those questions, we'll do that then. So that's how you get questions interspersed into this today. And also you get 1 HSW credit for attending today's session from AIA. That's also, of course, good for your licensure at DORA. Stick around to the end to get your full hour, and we'll give you instructions for how to do that. One thing we would like you to do between now and then, though, it helps, of course, to be registered for the event with an RSVP. So if you've done that, which is more than likely, because while you're here today, that helps us populate those credits. If you haven't done that or forgot if you did do it or not, Megan has a link in the chat feature that is on also something you can highlight in the bottom of your Zoom panel, and you can add that RSVP online registration to make sure that gets in there. We've also got GBCI credit available for today's presentation. So if you want that, we'll give you details for receiving GBCI credit. So without further ado, we have 2 great panels today from Ambient Energy. First is Renee Azerbegi. She leads the Ambient Energy Office and manages key projects by inspiring clients to create top-performing buildings based on resilient and regenerative design principles. Ambient Energy celebrates 15 years of energy commissioning and sustainability consulting for the new and existing commercial building market. Renee's favorite projects are zero net energy, water, and waste. Renee is currently volunteering with AIA Colorado's Awards Committee as well. So thank you, Renee, and welcome.
Thank you. Glad to be here.
We also have Linda Morrison. Linda's a PE and a lead AP. She's a principal with Ambient Energy. She leads the building performance engineering team to promote innovations and clear analysis that help clients to incorporate sustainability, resiliency, and regenerative design in projects and help to address the climate crisis. Welcome, Linda. Okay, without further ado, we will turn it over to Renee and Linda to tell us all about zero net energy and resilient buildings.
Thank you, Mike, and thanks AIA Colorado for having us here. We're so glad you can join us all today for a webinar on zero net energy and resilient buildings. I'm excited to give this webinar with my business partner, Linda. We've been working together for most of those 15 years. So without further ado, I will get started. Also, at the end of the presentation, I wanted to share with you a new update that we're excited about with the 2020 Colorado AIA Awards. And Friday, there's going to be a webinar on it. So hopefully y'all can, if you're interested in submitting an award, think about joining that webinar, which is also at lunchtime through the AIA Colorado website. So first, next slide, please. A little bit about our firm. We are a women-owned small business, and we're certified in many states, cities, and transit agencies. We're located on the 4th floor of the Metro State University Denver Aerospace and Engineering Sciences Building through a public-private partnership. We teach students, we take on interns, and we help grow the next generation of sustainably minded students. We have offices in both Denver and San Francisco, and our headquarters are in Denver. So you can see some of the sectors that we work on. You might recognize some of those buildings. Next slide. Our vision is that we are building the next generation of resilient and regenerative buildings collectively with all of you that can withstand the test of time. To demonstrate that, next slide, please. Looking at regenerative principles specifically, we've come up with the following graphic. If you have a compliant building, you're really doing code minimum. even if you have to meet LEED silver or gold for your city, for example, in Denver, it's gold, you're still just being compliant. And then if you work on efficient buildings, you're doing more than that. You're saving energy above and beyond compliance, or you're maybe getting to that next level of LEED. That would be an example of being efficient. Net positive would be producing more than you consume as it relates to, producing more energy, for example, than you consume, having more biodiversity, giving back carbon, for example, are examples of net positive. And then finally, regeneration is transformational change beyond the project boundary. How does your project influence change, influence positive change so that others follow? And we'll give you some examples towards the end of this presentation. So our agenda today is really talking about why we should care, especially during these strange COVID times, but even before that, of course. And then we'll go into some resilient design tools and strategies. We'll go through some case studies and definitions, and then we'll wrap it up. So as many of you might remember, in 2003, the Lions flood, that sort of shook Colorado up a little bit, as well as the many fires that we've had, to say, what are we doing about this change and how can we predict these things in advance? In terms of the representative concentration pathways, these are predictions of where we might be going with emissions and temperature over time. And there's things that we can do. We're following the dark line at the top right now, which is kind of the maximum potential RCP of 8.5 relates to 3.7 degrees Celsius increase. And that's not what we want to do. Fortunately, with COVID, we've reduced emissions by about 8%, but we know that a lot of those emissions are going to come back in 3 months or up to 3 years to get back to where we were, unless we can figure out what changes we can do today to help keep some of those emissions gains that we've had the past couple of months. For example, a lot of office spaces that maybe even architecture offices, they didn't really have strong telecommuting policies. Now everybody's working from home and a lot of people are enjoying it. So if we can maintain some of those telecommuting policies, obviously it doesn't make sense for some of our service industries to be able to do that, but a lot of industries are able to telecommute more. If we can start to think about which one of these trends can be long-term, we can start to realize some of the 8% savings we've already achieved. Next slide. So when we talk about resiliency, we're talking about how do we plan for disasters? And, we might say natural disasters, and we might try to plan around that. For example, in the plains of Colorado, we would plan for different natural disasters like tornadoes than we would in the mountain areas of Colorado. So we need to think about not just this particular state map, but really the specific vulnerabilities at your specific location. And so, for example, we were working on the schematic design documents for the Colorado Convention Center, and we just threw out the idea, well, is this a place where people would go if, say, there was a flood in Denver or fires in Denver? Is it set up for that? And they said, their response was, no, it's really not set up for that. We don't have any showers. That's what the rec centers are for. Guess what? COVID came, and now it's a place of refuge. You can't predict for everything that's going to happen and everything you're going to need, but you can do the best you can. And so there will always be a little bit of uncertainty about the risks you design around, but you still have to design around the majority risks that unfold. Next slide. So we've made some good progress over the past 20 years. We've reduced, 13 years, we've reduced emissions by 20%. So that's pretty fantastic. But we still have a long ways to go. Next slide. According to Architecture 2030, who said we had to be, they were the first ones who came out and said, we all really need to be net zero by 2030. They've actually come back and said, you know what, we need to do more. We need to do better than that. We need to be thinking about net zero in 2020 and existing buildings being zero carbon emissions by 2050. So we do need to be thinking about talking to our clients about how to be zero net carbon or zero net energy sooner rather than later, waiting for codes to happen. Because if you wait till codes to happen, you're just being compliant. Next slide, please. In California, they have been historically leaders in the energy space with goals of 2020 for residential. So if you build a brand new house in California today, you have to be net zero. And then they want all of their commercial buildings to be net zero by 2030. I think that, well, we'll get into a little bit. I think they're going to be about 5 years ahead of several other states, but many states are looking at changing their goals to be more aggressive, which is great because they realize that we haven't made a big enough dent in our emissions with the trajectory that we've seen. Next slide. So your work could really impact not just 11% of building materials and construction, but I would argue you really could have an effect on 61% of global emissions. If you think about the whole carbon, the carbon picture of buildings. Next slide. So for example, Green Mountain Power out of Vermont is actually taking on electric vehicles at homes and taking advantage of the batteries within those electric vehicles to become a virtual power plant. In 2018, they were able to use the 400 customer homes as a virtual power plant, saving $500,000 in a heat wave, which helped them avoid having to build another power plant or using their oldest, most polluted power plants. And I think we're going to see a lot more buildings designed to take advantage of the batteries within electric vehicles and more mandates citywide to become electric with our vehicles. It's an example of load reduction, and there's many different examples of peak load reduction that we need to be taking advantage of. Now Linda's going to talk more about embodied energy of materials. Linda?
So starting with what Renee had about the status of the carbon emissions trajectory we're on, this is one of the things that is a major contributor for that by 2060, we're projecting that basically the equivalent of a new New York City is built each month for the next 40 years, meaning that the embodied carbon of those new projects is also very important. That's shown here with information from Architecture 2030, that as the grid gets greener, and if you are an Xcel Energy customer, you've probably seen their plans for reducing the carbon emissions by 80% by 2030 for their power supplied and 100% by 2050. Certainly the operational carbon, those things which are the purchased utilities for a building, are going down in proportion to the embodied carbon of buildings. So we'll touch on that a bit in this presentation, and it is also something that is coming by code in a variety of jurisdictions in the Washington, Portland, California, and also Boulder has been investigating, looking at embodied carbon as part of the code compliance factors as well. And in recognition of the 2030 challenge and a desire to have lower emissions over time, ASHRAE 90.1 is the energy code standard. And here we see that it has been reducing over time. And while potentially this could go to zero net energy by 2030, right now it's slow compared to the imperative. And you'll see that, for instance, Denver and Boulder and other jurisdictions are doing above and beyond the ASHRAE 90.1 code cycle to reduce the energy consumed and the carbon sooner than that. This graph shows that information in kind of a different way. It's how far can a building go? And this was part of an ASHRAE research project published in 2016. which looked at a variety of 50 common on-the-shelf measures and where could it go. So if the site EUI of that existing commercial building stock for an office was 90 kBTU per square foot per year, and the baseline for 90.1 2013 was at 54, if you were to select all measures, we could get to an energy use intensity of 28. So one of the things that I want to share with you as we go through this presentation is some familiarity and context with site energy use intensity values so that you are more fluent in those. And so you can have a range and know how to set, and then also an appropriate number for your project. So you can have a real constructive conversation about that. But by applying those, all those measures, we're getting to a very respectable 28.5 kBTU per square foot per year, add PV, and it's either more than solar ready, it's zero net energy ready, or compliant with that. So moving into some design tools and strategies. In talking about resilient buildings, quite often we're thinking about that as in an interruption on the utilities to the building, an interruption in water, power, or something that makes the building need to stand on its own because things have happened in the community, like a tornado, where the building needs to provide shelter for a length of time on its own. And we think about them being resourceful buildings, robust, an ability for rapid recovery, and redundant systems as well. And intentionally built to survive and at least be able to perform their critical functions and maintain life-supporting conditions for the occupants during that time of need. One of the things that is a new twist on that is just what is happening in the future weather. As the climate warms, there are now projections in what that means to the heating degree days and cooling degree days. So this is information from that RCP of 8.5. So the worst case emission scenario, but it is business as usual and is currently the trajectory that we're on. And in each of these, the charts go from current time, the swap from gray colors to that red color is in about 2008. And then we get into the predicted model of where that's going. And you can see the trend of there's less heating degree days over time and more cooling degree days over time. So definitely part of that changing climate, changing design conditions, and also how the power grid, the susceptibility for fires, that kind of thing is also impacted by the change in climate and weather. And what does that mean in a different way? I like this visualization, which says if our Denver weather now is predicted to go to, using that RCP 8.5 in the 2080s, what's it gonna feel like? Well, it's gonna feel a lot like the Texas Panhandle. So moving from climate zone 5B to climate zone 4B, so moderate and dry. And well, there's nothing wrong with the Texas Panhandle. I think we all like living in Denver a whole lot more than that. And so certainly a reason, a very concrete reason to invest in energy efficiency and low carbon strategies so that we're not making this transition. So here's a few things about resilient things energy models can do today. So my team works with energy models, and you've probably seen an energy model used for a couple different things. They're commonly used for code compliance, to compare strategies against each other, and also in a performance rating system. But they can be used for a whole lot of other things. And some things that just the power of having a model that has system interactions for every hour of the year and can use a variety of different weather conditions behind it means that you've got a very powerful design tool at your hands. And here we're also highlighting passive habitability and thermal autonomy. We'll get into that just a little bit more. And those are really how to have human comfort in a time of crisis. So using the simulation tool and setting a survivability threshold, we can see a time of the power failure beginning and then the survivability through day 7 for a few different building enclosures here, with the high performance one maintaining a survivability threshold throughout the 7 days. And certainly that's the type of thing that we would like to be testing and designing for maximum robustness. And also setting thermal autonomy so that we can tell that hours of comfort in those conditions and maintain the hours of comfort and within the survivability boundaries and limit the hours that are too hot or too cold for that. Looking at some of the materials components, certainly global warming is the most important item and most directly linked to the embodied carbon of materials in the buildings. And we think about that primarily as concrete, steel, and aluminum, and in enclosures and structures as being significant levers for that. And I'm pleased to say that the LEED building rating system has really taken a step forward to encourage everyone to try a life cycle cost analysis, whole building life cycle assessment, and identify how they can reduce each of these impact categories.
The LEED also has a option for looking at resiliency. There's a pilot credit called Resiliency, where there's different options and you can get several credits in the innovation and design category. We worked with one airport to get to take advantage of that. Airports naturally think about these things a lot because they need to stay functional as long as possible. It really hurts their business if there is a natural disaster. So they have a lot of emergency response plans already. They did have to develop some more, but it's a matter of talking to them about what are they doing for each one of these options, and do they have backup power where they need it at the gates and things like that. So having those discussions with building owners or facility managers on campuses about what they're doing is important, and LEED sort of helps guide that a little bit in terms of this pilot credit. Oh, there's also, just to mention, I don't think we have a graphic on it, there's the Rely rating system, which is another thing that you can look at. It's more designed for large scale facility campuses, higher education institutions, airports and things like that, where they have a lot of buildings to manage and a lot of power to manage. But it's definitely something to look at least for best practices in terms of a resilient design tool. Now we're going to get into zero net energy definitions and resources. So the Department of Energy has defined zero net energy, or ZNE, as basically zero net energy on a source energy basis. So not just looking at what's on your bills, but also what's the source of the power from the utility and what's the carbon component with that. Because it's important to know if you have a green grid or if you have a dirty grid, or if you're somewhere in the middle, especially when you're looking at energy and carbon. Next slide.
And this is according to the New Buildings Institute. One of the things they do, in addition to advocacy, is to register and then validate zero net energy buildings. So this slide comes from 2018, and you can see that across the country, there are zero net energy buildings in absolutely every climate zone. So it's not something that needs to happen in a specific climate zone. All of them are fair game. And I would say that probably there's at least 5 times as many buildings that are ZNE or close to operating in that perspective who just haven't gone through the validation yet. So certainly a bigger population than just the ones listed by New Buildings Institute. So a little while ago, NREL put out this nice chart, which is looking at if you have just a given building, how would you quickly assess the potential for having a zero net energy building? One of the ways to do that is by the number of floors. So if you have a single story building, you're able to put, say, photovoltaics, a solar array on the rooftop there, and you have a pretty big an array for the occupied space below it. So that does get more difficult to have a zero net energy building by rooftop solar alone as the building gets taller. Taken, I guess, the wrong way, kind of the way that if you only had one single lens to look at a zero net energy building, you'd say, oh, good, we should have only 1-story buildings, then we'd be able to accomplish this goal. And clearly that is not the right direction for land use and other sustainability issues. So it's definitely a portion of a building with a high solar potential, like a warehouse, to be utilized for that, to make up for other buildings which might have higher process loads like laboratories or hospitals, or be high-rise residences. Looking again at the solar potential, so this is a map of solar resources across the country, and the assumptions here are that of all the solar radiation that is arriving at a building site, you'd have 20% efficient PV panels, which is still a good value for PV efficiency, a 2-story building, and have 50% of the roof area available for photovoltaics. And basically, what is the energy budget inside your building that you're able to get just by using what's available for rooftop PV? And in Colorado and in the Front Range, we're right in that 27, 25 kBTU per square foot per year for energy. And that's a very healthy budget for building types like offices, schools, and getting into higher process loads as well. Things like maintenance, repair, a little bit of light research, probably not enough for laboratory and hospital to exist on its own. Another thing that's made zero net energy buildings and distributed energy, so having more arrays embedded in the grid, it's just the price has come down. And you've probably, as the example about Xcel Energy making a greener grid over time, part of that is just straight economics, which are such a positive development. So we're now at $2 a watt or even less, depending on whether you have a large installation and economies of scale. And here's something that every project can do now, regardless of whether the client has voiced an interest in efficiency beyond code or tackling a zero net energy building, but to give them a solar ready roof. That roof is an asset to them. It's a revenue generating asset, so it's very important. And as architects, a few things that you can help to shape are that you make that as good of a roof as possible for producing solar power in the future. So in the Northern Hemisphere, we'd want to have equipment more clustered towards the north versus being in the center. That way the equipment isn't shading or taking the place of optimal PV locations. To try to group roof equipment together and leave 75% of the roof unobstructed that a structural allowance is given, and that there is some small capacity given in the electrical rooms and also in the panels, and that there's a conduit path. So all very achievable going forward. This kind of busy slide comes from the AIA's guide about building performance and how to integrate that into the design cycle. And at the top, we're talking about single aspect simulation. So not necessarily building an energy model that's trying to get absolutely everything right all at once, but focusing on massing and orientation, natural ventilation, solar shading, daylight and glare, and envelope and facade and thermal comfort to drive into the whole building energy simulation, which moves from a simple box model at the beginning of schematic design all the way to being a performance tool during occupancy and post-occupancy. When we're doing zero net energy buildings, we are very much working with the client and the user on what they're bringing to the building. Usually the design and construction team focuses on the orange half of what's brought to the building, the HVAC, the massing, daylighting, lighting, and the building orientation and the envelope. But just as important are what the user is set up for as far as their behavior, whether, for instance, they're open to doing things like incorporating the janitorial schedule into their occupied hours and eliminating some extra times when the building would need to be operational. So it's definitely a very conversational and interactive process to get to a zero net energy building. This slide talks about how the building, which is below the grid edge here, can interact with the grid itself. And a zero net energy building gives a lot of options for energy reduction, for demand reduction, for energy arbitrage, which would be a cost savings measure. So as the grid edge becomes controllable by demand response signals or a cost signal, there's a lot of options that a building operator has to control their building for maximum effectiveness and maximizing their dollars. So we wanted to move on into some case studies, which close out our prepared remarks.
The Denver Water Administration building is one building amongst 8 new buildings on a campus just south of Highway 6. And they decided from the very, very beginning, which is extremely helpful when the client helps establish goals early on, that they wanted to be different. They set goals of zero net energy for their administration building, LEED Platinum, and One Water for this building, with high levels of LEED for the other buildings as well. So I'm going to talk a little bit about that. Next slide, please. So the One Water concept is one that means that it's sort of like you, instead of having grid connected photovoltaics, you have grid connected water. So you're still connected to the utility. You just use as much as you can on site. So they have a rainwater system. They have a gray water system. They're using a lot of that for irrigation. They also have an interior system that is a ecological wastewater treatment system inside with the storage tanks are on the outside. But there's, on the next slide, I can show you. You can see, these are construction photos that I took, so they're not the best, but you can see that the lobby is where the plants are that have been treated to the highest level. But they're taking black water and they're converting that and they're cleaning it outside in different tanks, several different storage tanks that clean as each one goes from one tank to the other. and then they're watering plants. And there's also different layers, which, sorry, you can't read that, but there's different rocks and different materials to help clean that so that it's a very nice space. Once these plants grow a little bit more, it's going to be a very nice indoor environment right in the lobby. So they're really being a demonstration project. And the reason it's regenerative is because this is the first commercial project in Colorado to do this. They had to talk to the public health department, the state of Colorado. They're setting new water laws by being the first to do this with both rainwater for large scale commercial and with this interior black water treatment system. So it's exciting because others will be able to follow. They're still working out the details in terms of even just getting it permitted. So it'll still be a couple of years before lots of other commercial buildings will be able to do this as well. But it's definitely a regenerative project because of the water component of it. Next slide. And on the energy side, it also has a central utility plant, probably one of the most energy efficient central utility plants in Colorado, I would argue, with about 6 stages of heating and 7 stages of cooling. There's actually a talk tomorrow with ASHRAE, where one of our ambient energy commissioning agents and the mechanical engineer, if you want to get into the weeds on what's in the central utility plants and all the commissioning on that. But that they're using radiant heating and cooling distribution within most of the buildings, and they're able to get a really efficient system. They're also using the Denver Water's conduit. So they have a very big water line that's going right underneath the space. And so they're tying to that for heat recovery. And that's also quite unusual, but basically you're taking advantage of what you already have on site as an energy source and an energy sink. And so that's saving a lot of energy as well. So in terms of energy use, we always start with, you know, we define energy in the beginning, and then as the design comes along, we refine the parameters, and usually our EUI gets down further and further as we work with the design team to further analyze where it is. We're estimating that the design will come in at about 27 for this particular building, and then when
Let's see, I think I dropped.
so, next slide, please.
I think we've missed a little bit of your audio, or at least I did, Renee, but
Oh,
the PV, as it's online, it makes for a zero net energy building with an energy use intensity of 0.
can you hear me?
Yep, we gotcha.
Okay, so San Francisco Terminal 1 Center and Boarding Area B, it's a very progressive city, as you know, and they had, for the airport, they had actually put in their RFP that they wanted an EUI target of about 35 to 50 EUI for an airport. And the first question they said was, well, what's your existing EUI? And they actually knew it. A lot of airports don't because there's so many different kinds of buildings, but they knew it. It was about 180. And so I was like, well, that's a pretty big ask. So we were the owner's reps for energy and sustainability on the project, and we're also doing the commissioning right now. It's like a 10-year project, and we helped them define new goals. We did some modeling and said, you know what, 65 to 85, including all of your airport process goals, makes a lot more sense for your building type with your process loads. And guess what? They were able to get there with a lot of different iterations for both the buildings combined and averaged. They're 2 different design build teams. So we took the collective energy data from both, and 120 was B, regular code compliant case, 77 with all the approved EEMs. Now they're going to have a heat recovery chiller plant, and that's how they're going to get all the way down to 62, but it's going to take a few years before they build that plant. So we like to show both numbers, but that's still really fantastic for an airport with all the loads that they have, which are very unique to airports.
So looking at a different type of building, this is the Toyota headquarters that is over 2.2 million square feet, and it's located in Plano, Texas. It houses an office, a museum, also houses fitness, full service, food service for the cafeteria, engineering, and their data center. So a building with a variety of loads, some of them very high. So we worked with them for early energy master planning, and here's what they were able to achieve. So all buildings are LEED Platinum certified. The parking structures house the PV, and so they're at 8.8 megawatts of PV. They have a 36% energy efficiency cost savings, and then the renewable energy plus energy efficiency gets them almost to 60%. And their thought was that they're taking a leadership position. This is definitely something that promotes bioclimatic design, central plant efficiency, as well as incorporating renewable energy on such a large scale that they are showing leadership with the ability to impact the design community overall. And they could have covered even more of these buildings in their site with PV to have a higher offset, but they thought that they would probably use a combination of PV on site here and wind, because there's such a great wind resource in Texas, for their carbon neutral goals overall. I wanted to highlight the City of Fort Collins and the Utility Administration Building. It's also called 222 LaPorte. Over in the right-hand corner is a building that's kind of gray. It's called the Butterfly Building. It's a historic building. That's not what we're talking about. We're talking about the building that's tan and brick behind that. So the Utility Administration Building opened in 2016. The City of Fort Collins, in their planning for that, knew that they were going to be taking a leadership position. They wanted to enact their climate action plan with this building, to have a zero net energy and ready, because they knew that they weren't going to take this building on its own to be completely zero net energy, and a LEED V4 Platinum project. This was the first office project in the state of Colorado to have a LEED V4 Platinum certification. So part of what they did was a very nice envelope. If you've watched the City of Fort Collins, there's a lot of attention to enclosure details and reducing infiltration. This building also had very intentional placement of windows and amount of glazing, a high performance, high insulating product that basically it's a suspended coated film, which works like triple pane glazing, but without the depth of the insulated glazing unit that a triple pane does. And then also light louvers for daylight redirection into the space, and exterior sun shading. There's a little bit of the lighting and daylighting look and feel of that building. That picture in the middle lower part shows the performance of the light louver product there. And then here's a little bit more about their plant. They're using, they have plans to have a future geo-exchange loop for a heat pump system. But at the moment, they're doing a water source heat pump system. The Denver Water Project that was mentioned earlier also has a heat pump system. Certainly, that's a technology that's very conducive for this type of projects with a zero net energy goals. It's not the only one, but it certainly is a very common strategy for that. And as they redevelop the rest of the city block there, and they would have even more buildings and assets that can plug into a geo-exchange loop together, and they'll have a better cost benefit on that capital investment. So hence it's going to come in a little while. Right now they're using a boiler and a cooling tower to temper the condenser water for those heat pumps. And they also are planning to work this into the Fort Zed district with energy storage. They now have energy storage in the operating building as of just a couple months ago. So one of the first projects with an operating storage system in Colorado. After the building was built, some measurements were taken. So part of this shows the data loggers to assess the energy that's used in the building. And over on the left-hand side are some statistics about infiltration. So the IECC would allow 0.4 CFM per square foot at 75 pascals. The city of Fort Collins has a lower code than that at 0.25 CFM per square foot, or at 75 pascals. What they actually achieved was 0.094 CFM per square foot. So 76% reduction on that 2015 IECC value. So an excellent building envelope, and just a testament to what the design and construction teams can do. And here's their array. This doesn't get them to a zero net energy building, but they have a 104 kW array. That's what they plan to put on the rooftop. That's what they had in their budget. And here again is some operating profiles for it when the building is beyond what the array is producing, and when it is running the meter backwards. And a look at that energy modeled data again. We started with a regional median of 82 kBTU per square foot per year. And then as the design progressed, we're getting lower and lower. And so the orange box is where we were at the end of design at 26 kBTU per square foot per year. And then comparing that to the yellow, which is a year of actual measured data for the year 2017. And we're also right at 26. I love it when that happens. We really do try to refine our energy models so that they are a good reflection of the operations, but really that operations are the most important thing there. And then after the PV array, we get to an energy use intensity of 15.5. So quite good, and setting them up to be that operating zero net energy building. One thing that I wanted to say about how the energy is allocated in the building, it's interesting, but quite a bit of this is the green for, in this case, receptacle equipment. So office equipment, the computers, monitors, copiers, other office equipment is still a pretty significant value. So the context of an EUI, I hope you're taking away that a value of, say, 25 might be a good place to start a conversation on a building in Colorado. It's certainly something for a team to react to see whether it's appropriate for the building type. And in Colorado, probably a very appropriate starting goal as well for a building. And our last case study here is about a microgrid that was not only zero net energy, but intentionally designed to stand alone as a water treatment plant so that potentially it could operate independent from the grid for a series of days. So that included photovoltaics. It also included hydroelectricity, pumped hydro. So basically you're using water as a battery to pump it to a higher elevation where you can take the hydro power at the time that you need it. And then 2 different kinds of storage with a flow battery and a lithium ion battery as well. And so you were able to demonstrate that this project, if they chose to, could move forward as a standalone zero net energy building and to do all their process equipment for an entire year. So hope that gives you some good ideas on what to bring to your clients and some discussions, and how you might want to use the design process and some of the tools and analysis in the future, and how to couple that with operations, planning for operations so that they can successfully track building energy use by end use, and also the generation on the building, and then also how to think about resiliency and how to stand alone in the case of an emergency.
I
Could
mentioned
I interject real quick? I got an attendee question on the case studies. Are you aware of any related to residential or single family?
There's an absolute ton of residential and single family case studies in Colorado. The city of Boulder has basically required that residences have been zero net energy building for the last couple years. So that's 100% of that building stock is zero net energy. And certainly there've been more than a decade of residential buildings that have striven for being a zero net energy building, and many of them accomplishing that.
And any off-grid home is going to be a net zero energy building, and Colorado has quite a few of those in different parts of the mountains and stuff like that. Net zero energy for homes tend to be, often going electric. The older versions in the 70s, they tried to use solar thermal and big, huge solar thermal storage tanks as well. But I think the trend has been to go electric, and actually the trend in commercial space too is to go all electric, because our source energy from where our emissions are coming from is getting cleaner and cleaner, with Xcel Energy having requirements to actually be, I think net zero or zero emission. I want to say, is it 2030 in Denver or Colorado, Linda? Do you remember?
The grid overall for them is zero emissions by 2050.
Yeah, for all of Xcel Energy's territories, but it's even more strict, I think, in Colorado by 2030. So we'll have a pretty green grid soon. So it makes sense to go electric with heat pumps, with efficient systems, not necessarily with electric heat, but heat pumps or ground source heat pumps, something where you can get a high COP, more than one, which is what electric does for you. But I did want to mention that there's going to be, I think Colorado's maybe first, AIA Sustainability Award. And we've been working with others, with the whole committee, the AIA Awards committee, to develop a tool. It turns out that other states have been already having something similar. And one of the states actually developed an app. It's actually an Excel spreadsheet. So there'll be an Excel spreadsheet that's online, I think as of maybe tomorrow, with a presentation about that, as well as all the other awards, which some of them have changed slightly from what they were just last year. So if you are interested in submitting an award for one of your projects, I think you should tune in on Friday. And this is sort of this cool spider graphic that comes up with an area graphic for the reviewers to see how sustainable you are depending on your answers to the questions. So are there any other questions?
Yeah, we had another question, and I think I know the answer. So it was, how can we access the case studies? And I will say that this presentation itself will be available in its entirety for people to review later, or if you had colleagues who you think this would be good for, that'll be available for them. And the PowerPoint slides will be made available as well. I can make that request, right, Linda and Renee? So as you look at that, and then our editorial committee, we have Lauren Dundon, who's an AIA member on that editorial committee, who's writing a story in a future newsletter about the residential side of those case studies and net zero design for homes. So you'll see more on that. Thank you, Linda and Renee. I'll give some of the questions that have come up over the hour as well. But I just want to say, I don't feel like moving to Montana to enjoy Colorado's climate in the next few years. So this is definitely something that everybody should take seriously if we want to continue to enjoy where we live and take care of the planet. I know that there's been some, I don't know if controversy is the right word, but not necessarily wide acceptance of looking at the source side to meet the goals. But that's changing in terms of the 2030 commitment and how you count reaching that challenge. What are your comments on that? Is that a viable tool in the toolbox?
I'll take a first crack at that. And I'll go just in the frame of reference on the city of Denver recently updated and adopted their amendments to the IECC 2018.
Mhm.
And there was conversation about whether source should be part of that or not. And because the grid is greening so quickly, they felt like instead of being a helpful design tool, that it would really be complex math for the sake of complexity and would steer resources away from good demand side, good building side design. And so wanted to limit that because they'd have a high probability of achieving a very green grid, 80% of the way there by 2030, and then the rest of the way there by 2050. So they did that less of a philosophical reason, but by saying that there's a foundation for improvement and to use the efforts towards designing a good building. And I'm pleased that that does hold up in many parts of our state. We have a patchwork of different electric providers. We've had a historic predominance of coal-fired generation in our state, but many of our utility providers have made significant commitments to greening their grid. If you're in a place that does not have a commitment to greening their grid, then I think there's more thought process to say, are we fully getting the benefit out of, say, an electric hybrid heat pump system? Does that truly pay off, or would focusing on other things that are appropriate for our climate, like evaporative cooling and a natural gas boiler, would that be a more appropriate condition? And you can test that. And you can test that through a long-term looking 10 or 20 years into the future on where the embodied carbon of the grid is anticipated to be. So I think it depends a bit on the utility provider and what their plans are.
Yeah. That's some good feedback. I know it's going to be, there's not a universal answer to every one of these questions. It is situational, and it also depends on what the client's willing to do. They may not be as ambitious as the design team on some of the demand side things, but you could get there on the source side to make up that gap. One thing that really caught my eye was you talked about the survivability of buildings, and there's not a lot of difference between a typical building and the ambient outdoor temperature. I mean, it's quite literally shelter and not much else. So how much do you think codes are helping us move in the right direction? I know there's stretch codes that Denver's looking at and some other municipalities, but also the model codes themselves are getting more ambitious with things like solar ready appendix or net zero appendix. Can you comment on some of the code developments?
We were involved with the latest energy code adoption from Denver, reviewing the changes there, and it was an interesting process. It seems like that Denver adopted a code that's, I want to say, maybe 10% better than the IECC code, on top with all their different changes and amendments. So that was encouraging. But again, just meeting code isn't going above and beyond. You have to do it. So we still encourage our design teams to see how we can go further and how we can go beyond code. Because if we just sit around and wait to do code compliant buildings, we're not really going to meet the global climate challenge that we face today.
And part of a building standing on its own and maintaining a passive survivability comfort would be an improved envelope. And we're getting higher insulation values as part of code, so that is definitely helpful. We don't necessarily build in a large amount of thermal mass. So that would be something to test to improve the passive survivability of buildings, as well as features that don't require a powered fan to run to bring ventilation air. Or if it is a fan for ventilation air, that is a system that is renewably powered with storage so it can operate 24/7 and appropriately sized.
Well, just one or two more questions before wrapping up, and I'll get to those after a quick reminder. If you'd like credit today and you're only concerned about the AIA side, we just need your name in the chat for the record of making that processing easier. If you would like Green Building Certification Institute, or GBCI, that's the designation that comes with the US GBC and LEED. The folks here on the call today have offered to process that for you. What we need there, though, however, is your full name and email address for that to be processed. So again, for AIA credit, just your name. If you'd like GBCI credit, your name and email address, please. So two things. First would be, is the fluctuation in energy prices or utility costs a factor that move the needle one way or the other? And then the last thing I'll ask is just any parting thoughts or encouraging words after you answer that question for our participants today.
Sure, I'll start with the energy cost question. So energy costs definitely make a difference. I remember it seems like a long time ago now, but we had a spike in natural gas prices that at the time made biofuels appear to have a better financial case than a grid-tied fossil fuel natural gas source. So absolutely makes a difference. And some of the market signals that are coming to us are time of day pricing, so that if you're able to generate or store power at a facility and then either run on your battery or sell it back, you're doing energy arbitrage, and that can make a huge difference to your building itself. It might not, there would be a financial benefit to it, but the bigger industry-wide or societal benefit is a smaller operating sources for the grid itself, and maybe fewer power stations because of the distributed energy that exists inside the grid. So that's really where the benefit is. And those signals in the marketplace are here, and they're only going to get stronger.
As far as
last word on our thoughts of optimism.
Right. So I would say, don't assume that your client just wants a code compliant building. Ask important questions about resiliency planning and natural disaster preparation. Ask questions about energy. Do they want to have a low EUI building? Do they even know what an EUI is? Starting at the basics, and help them set goals and show them the importance of it, because it's our clients who kind of need to set the direction and drive this, but I think we can help influence them a little bit.
Well, Linda and Renee, thank you so much for an insightful presentation today. I know it was an eye-opener for me, and I hope it was for everyone joining us today as well. We do have a couple more coming up. So tomorrow is the 2030 commitment. Are you ready to meet the challenge? That'll be at noon. And that's got some great content as well. And then Friday, if you'd like to learn more about the awards that are going out for call for nominations and the new category, which we're of course very proud of and had some great help from Renee to help develop, you can tune in Friday at noon for that as well. So hope to see you again soon, and thanks again for joining us.